So today we have the great pleasure and honor to welcome Professor Philippe De Wilde, who is the guest speaker of today. And maybe I will start by briefly introduce him. So Philippe De Wilde is a professor of artificial intelligence in the Division of Natural Science at the University of Ghent in UK. He promotes the use of AI and machine learning in bioscience, medical science, and physics. He works in the context of digital humanism on transparent and humane AI. Between 2014 and 2020, Professor De Wilde was Deputy Vice-Chancellor for Research and Innovation at the University of Ghent. And between 2017 and 2014, Philippe was head of the School of Mathematical and Computer Science at the Heriot-Watt University, with campuses in Edinburgh, Dubai, and Malaysia. He has a PhD degree in quantum mechanics and a master degree in computer science in 1980-85 from the Ghent University, Belgium. And he was previously lecturer, and senior lecturer in the Department of Electric Engineering at Imperial College London between 1989 and 25. So the title of your presentation, Philippe, today is Large Language Model, ChatGPT, Bard, and WuDao. So WuDao, from what I understand, is a Chinese large language models that is very similar to ChatGPT. And apparently, I asked some of our colleagues here at UNU Macau, the meaning is of WuDao is understanding the truth. So it's something interesting for large language models, I guess. So it's a great pleasure and honor to have you today, Philippe. So the floor is yours now. So you have something like 30, 40 minutes for your presentation. And after that, we will have a Q&A session with the audience. So thank you very much.
Okay, thank you, Serge. And thank you the whole team at the University of Macau for setting up this talk. It has gone very smoothly, so thank you for your work. As Serge explained, we are here today to share some knowledge about GPT and about large language models. I strongly believe that knowledge sharing should happen across the world and should have no national boundaries. So really what I believe is that all universities in the world should be United Nations universities and should subscribe to the ideal of a United Nations or a global university. So I'm so glad to give this talk in this series. So I'm going to talk about a number of large language models, ChatGPT, Bard, WuDao, and a few more. You're going to see that on the slides that follow. Sorry, I have a problem switching. Okay, here we go. My experience, as Serge said, I have a long academic experience in university management as well as researcher. I have worked for about 37 years on the algorithms that underlie what is now called deep learning. And I'm very proud of that. I've been a contributor to these algorithms together with many thousands of researchers across the world. As I've worked for so long in AI, I think it's worth taking a historical look at AI, because if we want to understand the future, it can always help if we understand the past. Of course, we can't predict the future of AI, but for just one slide, I want us to reflect on the past of AI and also to see how cyclical AI has been, because it may well be cyclical in the future as well. A lot of AI started around 1955, so this is not a new area at all. It started around 1955 with the summer school at Dartmouth College in New Hampshire in the United States, led by John McCarthy. And things went well, things grew in machine learning and automatic learning. Things started growing well from 1955 until in 1969, two researchers, Minsky and Papert, published a book showing that a certain type of machine learning algorithm, which is called a perceptron, showing that this could not implement a certain logical function called exclusive OR. And really, if you that book is still available, if you go back to that, it's full of very technical arguments, and exclusive OR is just one example of a logical function. Also, the perceptron is a very, very restricted algorithm. So fundamentally, this was not so bad. But Minsky and Papert were so influential that they really pushed down the evolution of artificial intelligence from about 1969. For a long time, for more than 10 years, we had an AI winter. And then in the 1980s, things started going well again because we had expert systems. And there was in the 1980s an enormous hype around expert systems, actually similar to the hype that there is now around large language models and GPT. And I'm going to go back to expert systems in a minute because I think their rise and fall can teach us something about what may happen with large language models. So there was a summer of AI in the 1980s. And then in the late 1980s, expert systems crashed. I'll explain in a minute why that happened. So we had another downturn on AI. And now what we're living in is another summer, another AI summer from about 2010, when deep learning was made possible by powerful computer hardware. The algorithms for deep learning had existed for a long time, and it's the ones I worked on myself in the 80s and 90s. But really in 2010, the hardware allowed us to implement very powerful deep learning algorithms. So we're in a summer of AI, and we should enjoy it, but be aware that AI is cyclical. Going back now to expert systems and how they came about. Actually, expert systems grew for about 2000 years. It started with Plato, Aristotle, ancient Greek philosophers who claimed that reasoning followed logical rules. So they kind of developed and invented logic and said, look, all reasoning, all proper reasoning should follow these rules. And this train of thought has lasted for a long time. And I just want to mention Boole, George Boole. You may have learned or heard about Boolean algebra, which is one of the bases for computing. So Boole also strongly advocated the idea that reasoning should follow logical rules, and that was the only way to go. Then more recently, famous philosophers, Wittgenstein, Chomsky, these are amongst the top of philosophers in the Western world in the past century. They developed an analytical view of language, which was in the line of essentially what Plato and Aristotle had started. It was analyzing language with a bit more subtlety than just plain logic, but it was the same kind of way of working and the same look at languages. And the work of all these people over such a long time has influenced the development of expert systems. Because expert systems, they still exist, are collections of if then else and other logical rules. So it's basically if something, then do something, or otherwise, if it's not the case, then do something else. So that's what expert systems are. They are huge collections of logical rules. And expert systems had an enormous promise. I'm talking about the 1980s here. They were going to help with medical diagnosis, with scheduling, with robot navigation, also advice at home, how to repair something, how to cook, etc., how to do your finances. So there was an enormous promise around expert systems. And they would learn from human experts. That was the basis. That's also why they were called like that. So you would take human experts in medical diagnosis or in scheduling or in cooking, and you would ask them what rules they followed, and you would implement them on a computer. And this worked well until it was realized that human experts do not follow logical rules. And psychologists discovered that behavioral psychology, for example, made us realize that the basic premise of expert systems was not going to work because humans don't follow logical rules. So we would never find these rules that would essentially allow other humans to follow them and be successful. And that was the downfall of expert systems and logic-based AI. As I say, they're still around. They're not bad fundamentally, and you can try to fix them. It's just they form a very, very small part of AI as it's currently being done. The current AI is all statistical. And I want to take some time to explain what this is. I promise you I won't use any statistical formulas, but I'll try to give you an insight in the statistical nature of current AI. This started in the 1980s when there were attempts at machine translation. Both in the European Union and I'm sure in the United Nations as well, there is an enormous need for translation of documents. And in the 1980s, computer scientists looked at how to do that by computer. And the way they went in the 1980s, remember, this was the heyday of expert systems and of logical analysis. So what was done for machine translation was using grammatical analysis of sentences and also logical analysis of semantics, that is the meaning of sentences, were analyzed logically, and dictionaries were used. And this failed. So there was an enormous, again, a lot of effort because human translation is so tedious and so costly. And in the 1980s, the attempts were made to use logic-based systems to do machine translation. And it didn't work, just like expert systems basically didn't work. What happened in 2006 is that Google Translate uses statistical machine learning to translate. So they dropped all the logic and all the grammatical analysis and just use statistical machine learning. I'll give you a bit more detail in a minute, but they did not use logic to understand the meaning of the text. So they completely dropped the idea that you have to understand the meaning of a text to be able to translate it. And this is one of the premises, one of the bases of GPT as well. And that's why I want to mention it here. So this started with Google Translate, ignoring the meaning of the text and still being successful if you use machine learning. So Google Translate, what do? Well, they use a layered neural network to learn patterns in translation. And the word pattern is important here. Google Translate does not memorize these patterns, but stores them as a collection of numbers. So the patterns are transformed. They are not stored literally. And this is also what happens in GPT. I'll tell you in a minute. And the learning algorithm for Google Translate prevents the neural network from storing the patterns verbatim or literally. So actually the algorithm prevents the software from storing any patterns literally. And it turned out that this allows Google Translate to be successful on patterns it hasn't seen before. So I want to read this once more because this is not easy to understand. But essentially, if you prevent an algorithm from memorizing things literally, then if you do that well, then you're helping this algorithm to operate on patterns it hasn't seen before. So if you memorize things literally, you struggle to generalize your knowledge. And Google Translate is extremely effective. And when I go to China, I see similar algorithms being used everywhere and actually being essential in the communication between Chinese speakers and English speakers. And really it's happening across the world. So the techniques that Google Translate started, these statistical techniques are being used now. And since then, all successful AI, not just translation, has been based on neural networks. Now a little bit of detail about large language models. What I'm going to tell you are approximations and things I've glanced from reading the literature and also from talking to people who work on large language models. But the companies developing these models are quite secretive. So there isn't really much open source large language models. There's a little bit, but the main ones are quite secretive. And I'm just giving you some words here to get familiar with. So Google has a number of large language models: BERT, Lambda, BART, Palm 2. They have been making enormous investments in these. And so currently BART is somewhat similar to GPT. If you only use GPT, well, then Google's models are similar. And then OpenAI and Microsoft, who collaborate tightly, and Microsoft invests a lot of money in OpenAI. They have GPT-3, ChatGPT, GPT-4 now, Bing Chat from Microsoft, DALL-E. And this is being developed further. But certainly right now, GPT-4 is a very powerful model. Unfortunately, for it to work well, you have to pay for it. So not only is the software quite secretive, but it's also something to generate income, of course, with the level of investment. You have also Meta. Sorry, I nearly forgot Meta there. They have a model called Llama 2, slightly different from the others. I'll comment on that in a minute. But one of the points I want to make in this talk is that China is also a large player in large language models. And that's not always obvious if you live in Europe or the United States, or I would guess Latin America or South America as well. China really is a large player, and I've chosen one of their models, Wudao, to be in my title, just so that you see the Chinese characters, hopefully learn to read them and pronounce them correctly, but also so that you have a visual reminder that China develops large language models. But other models are called Ernie, and there are other companies. It's not just Baidu. There is also Huawei and Alibaba, for example, who are involved in large language models. There are smaller companies, Anthropic with a model called Claude, Inflection, Cohere. So there are a few smaller companies. Now, what do these models need? And again, these are rough estimates. Typically, they need about 400,000 processors to run. And one update, so if the model has to learn new knowledge, such an update costs between $5 million and $35 million. These are very crude estimates. Meta's Llama 2 is a slightly smaller model. On the other hand, for GPT-4, I've heard a mention that one update actually would cost around $100 million. So extremely intensive in terms of computing power that is needed for large language models. A lot of processors and a lot of computing time to stay up to date. What you notice here is an absence of the United Kingdom, of Europe, of the global South. And I put that in red because I really regret that. Europe and also India are technically entirely able. They could have been first. They invest in artificial intelligence. They have the people, they have the traditions. But also, why not? Why couldn't there have been, for example, a Spanish large language model to be first in the world? But no, we see time and again that large language models and other advances in computing always come from the US and now also more and more out of China. And I really regret that there is not more activity across the world, because it is possible. It's technically entirely possible. A bit more technicalities here about large language models, and I hope to convey to you that they're not original thinkers in no way. So again, they use a lot of parameters, about 1 trillion parameters. Again, this is a ballpark. Some models are now slightly smaller, but we're still talking about 70 billion parameters or 100 billion parameters for the so-called smaller models. And they're trained on about 1 trillion words. And if I can be a bit UK-centric here, 1 trillion words, that's about 1 million Shakespeares. I find this actually not that much. So the training set is large, but then again, not that large. I think 1 million Shakespeares, because don't forget, this also includes computing languages. This involves lots of things. This involves Wikipedia. And of course, large language models take input in multiple languages, not to the same amount in all languages, but they do take input in lots of languages. So I think 1 million Shakespeares is actually not that much as a training set. They learn to predict the next word from approximately 1,500 preceding words. They learn images, and they learn from user feedback. They are also being trained by users, trained to be safe. So the users implement or help the algorithm learn heuristic rules, for example, to filter out offensive language. Now, although large language models have as many parameters as training words, here again at the top of the slide, there are 1 trillion parameters for 1 trillion words. So you could think, why not just memorize these 1 trillion words? You would need about 1 trillion numbers to do that. But they're not doing that. And remember what Google Translate does. Well, it's the same in large language models. They have a certain kind of randomness that prevents them from remembering strings of words verbatim. And it's that randomness that allows them to deal with inputs they haven't seen before. So what these models do, and this has been coined by Timnit Gebru and other researchers, they are stochastic parrots. So they essentially repeat what they have learned, but not literally. So the repeating is the parrot, but doing it in a sort of random way, but it's an intelligent random way, is the stochasticity. So large language models are stochastic models, a term coined by researchers that are at the end of my slides. Allow me to drink some water, sorry. Large language models are political. They are trained on census text, although the text they are trained on, as I say, about 1 million Shakespeares, it's still selected. It's selected by people who develop these algorithms. These people are mainly young, they are mainly male, and they are mainly based in the United States or in China. So the text is censored, it's selected. They are not trained on text inciting violence or terrorism or conspiracy theories like anti-vax. However, what is terrorism and what is a conspiracy differs from country to country. And that depends on politics, on religious beliefs. So if you use GPT or anything like it, be aware that you're using something which is biased in a certain way, politically or religious. You have to be aware of that. In the future, and less controversially, we will also see more specialized large language models, for example, for medical applications, for management. They are being made. I also hear that American services like CIA and the military will develop their own large language models. And there we will see large language models with different political flavors. And I think that's important for United Nations audience. We are going to see a global spread of a variety of large language models. Next slide is that you may have seen a document signed by some high-profile researchers, a minority, but high-profile ones. I think Bill Gates was one of the signatories, saying that there is a risk of extinction from artificial intelligence. I want to rebuke that and just point out that there is no scientific evidence for such a claim. And I want to compare extinction from AI with, for example, extinction from an all-out nuclear war. In that case, you can calculate what may happen. You can calculate the number of warheads, how strong they are, how much dust they're going to bring in the atmosphere, and how much direct and indirect casualties there are. So you can have scenario for an all-out nuclear war. And in certain scenarios, this will indeed lead to an extinction of humankind. And it's the same for pandemics and global warming. You can calculate things, and for certain scenarios, all of these disasters could lead to extinction. But this is not the case for AI. There are no calculations. There is no scientific evidence for showing that there is a risk of extinction. So I just want to rebuke that. Of course, it's worth thinking about it, but what we would need are models as we have for global warming, for example. I've mentioned stochastic paradox before, and I want to point out, this is from an article in Nature, where they have looked at how disruptive science is and how original scientists are, because we know there is a huge increase in the volume of scientific output. And what these researchers found is that real disruptive science is dwindling, is going down. And you can look at these graphs here. They have them for social science, for technology, for physical science. Of course, this is based on a certain measure of what disruptive is, and you can well query that measure. But I think it's worth looking at that paper and looking at the measure. It's decent work. So what we notice is that although science output has increased massively, the degree to which it is disruptive is decreasing. And this is apparently unrelated to ChatGPT, but I want to link these two things. And I think that ChatGPT holds up a mirror to us all. And so it's a stochastic parroting system. So it essentially tells us what it has learned, but in a slightly random way. It does that superbly well. For example, it generates mostly grammatically correct sentences in a variety of different languages, but it does more than just parroting what it has learned. I think the way it does this, it has also learned from us. If we look at just what is happening right now, and I've mentioned the enormous increase in output volume in research, but this happens not just in research. Students have to write more and more essays, academics have to write more and more grant applications, policymakers have to generate more and more and longer policies. The media also have to create lots of news stories. It's not just newspapers anymore. You have all the electronic media online, and there is an enormous variety. And to create content for X, as it's now called, or for other social media. So what we are noticing is an enormous increase in just volume of output of anything, not just scientific knowledge. And what that leads to is a lot of incremental output. For example, news media taking over, copying things from each other. There is lots more copying. There is lots more parroting going on. Policies as well. In the United Kingdom, universities are quite independent. They all have policies around plagiarism, around preventing harassment, etc. They all have their own policies, but really what they do is parroting the policies of other universities. They're all very, very similar. So what we see is we see an enormous increase in volume of output, but the increase is incremental, it's small, and it's produced from a mixture of sources, and it has little or no originality. We see more and more copying, which is not bad if you copy something good. But if you copy fake news, for example, this spreads in this huge process that generates more and more output. As a result, readers are overloaded. We spend too much time on social media just taking in all this output. We're overloaded. And if you're overloaded, you're going to prefer reading familiar documents because they're easier to understand. If you have to deal with a larger and larger volume, you don't want to have to deal with lots of complicated or original thoughts. You want just standard fare that's easy to take in. So essentially, ChatGPT has learned 700 gigabyte of stochastic parroting, but it has learned that from us because the texts it's using are things that we have produced as part of this ever-increasing volume of outputs that we generate. And we generate that largely by imitating other work. There is less and less original work. And really, I think the success of ChatGPT is that it's operating just like we are all operating right now in dealing with huge volume of output. And actually, ChatGPT is going to help us to produce even more output. And it's going to be even more bland and more standard than it is now. So ChatGPT is holding up a mirror to the decline in originality. I think that's an important point, and maybe we should do something about it, but because I hope that we all regret the decline in originality. And this is my last slide here, taking up the challenge posed by ChatGPT. So I think ChatGPT and other large language models, they're not just useful tools, they're also challenging us, and we should react to it in a positive way. And here are a few bullet points on how I think we can react to large language models in a positive way. So how can we produce documents that are distinctive from those ChatGPT can produce? A lot of my students have given up already and are just accepting that ChatGPT is going to write their essays from now on. Well, I think we shouldn't give in to ChatGPT. We should keep fighting to produce material and ideas that are distinctive and novel. I think we need to revalue what is originality and what is disruptiveness, not just in science, but also in policy making, in the way we write about what we do, in what we expect from the media, from the press. We need to revalue what we want and ask for higher standards. This is only possible if we reduce the volume of output expected from students, academics, and policymakers. I think we should read less, but we should expect to read better content and more original content. And I think this is what we ought to take from ChatGPT. We should refuse to have all our content produced by ChatGPT and large language models or by people who are using them. We should ask for more. ChatGPT is a safe way to avoid failure. If you have to write something and if you want to avoid failing, well, have it written by ChatGPT. On the contrary, I think we need to value ideas that can fail and also support creators who have failed. So this is my conclusion. I hope I've given you some insight in how ChatGPT works and that it is mostly based on statistics and on stochastic parroting. And I hope I've also shown you or made you think about the huge volume of material we take in and how bland and how little original it is. And I hope I have convinced you that really we need to rethink what we want in terms of original ideas, and we need to support the people who stick out their neck, those who don't use ChatGPT, and go for something really original. And I hope we can all work on that. Thank you for your attention. And if you look at the slides, you'll see there are a few references here at the back. I will stop screen sharing now. Let me go out of this.
Thank you, Philippe, for this wonderful presentation. So I guess your presentation will generate a lot of reactions and questions from our audience. So we are moving now to the Q&A part of this webinar. So if you have questions for Philippe, please, I see already some virtual hands, so you can raise your virtual hands. So maybe I will start with the first question. So about the cyclical part of AI, because I totally agree with that. So many times in the 70s and even when I was doing my PhD, I remember that we oversell a little bit the AI at that time. Yeah, I remember I was working on the first, I implement some neural network and it was solving some basic problems and even during the Dartmouth workshop, this foundational workshop in the 1956, if I remember correctly, the researcher at that time, they say, okay, yes, give us 6 months, one year, and we will solve all the problems. So it happens many times that we oversell all these technologies. So how do we know that that the new AI winter is not coming, will not start soon? So because we are, especially in the context of large language models, they are producing lots of hallucination, and there was a lots of people who register to use ChatGPT, but apparently there is less people using the ChatGPT nowadays. So how we can produce technologies that are not at the end deceptive for the people, and yeah, so I'm want to have your thoughts on that.
Yeah. I want to say two things to that. First of all, it's impossible to predict exactly when a crash will happen. Also, if you look at the cycles in AI, actually, it's not like every 10 years or so, it's plus or minus a number of years. We also know, for example, from the stock market, it's impossible to predict exactly when a crash will happen. what I do want to say, that's my first point, is that if we look at the past, it is well possible that there might be another AI winter, and that at some point in the future, next 5, next 10 years, people might turn away from AI because by then it will have been fully integrated in a lot of applications, and there could well be a time when people are turning away from it. My second point is what is, and your question really, how can we save what is valuable? I think we can save what is valuable by having stable scientific and research communities, and I include business and industry in that. If we have stability over a long time, stability that goes across the cycles, and I think then we can safeguard what we have developed. You can see that if you look at IBM as a company, they have gone over a number of cycles, and I think managed to safeguard some very valuable things. Microsoft as well, and of course universities, many universities who have been around for a long time have been part of that. So we need stable communities to help us over cycles and over fashions. Okay, anybody else? Or
well,
Fernando.
I'm with my hands raised. I don't know, Serge, what's the order?
I think Serge has frozen for the moment.
Yeah,
Okay.
so please go ahead, Fernando.
All right.
Okay.
So first of all, Jingbo, thanks for the organization, and Philippe, as always, your presentations are very, very clear and insightful. Well, first I have to acknowledge many points, and I agree with you that it's a challenge we have ahead. We don't know for how long, but it's definitely a huge challenge. I liked very much when you touched this point of the mirror, because what I find is that the problems with ChatGPT are not with ChatGPT, are with us, because this is just reflecting ourselves. You see, when we talk about biases in intelligent systems, it's basically the system learns who we are. And along this line, my question would be on the how part of it, because it's we will not stop the wheel of science at all, like some colleagues have proposed months ago. We will not. But how can we prevent that let's put it like that, the evil part of humanity that ChatGPT is incorporating slowly can accelerate some problems that we are likely to face without ChatGPT? Because this is what I think right now. With these new technologies, we are just accelerating the human quest, let's put it like that. And just to finalize, I know it's a difficult question because it's not very clear to me as well, but it's on the how part, because we cannot stop it. It's powerful. It will attack the very core of humans, which is the creativity, it's a challenge. But how do you see or the role of academics, researchers, universities in tackling the side effects of all that? Thank you.
Thanks, Fernando. I think technology is about humans. Technology is really not about computers or electronics or whatever. Technology is about humans. And to take it back to your talk, which I enjoyed, and when you talk about responsible AI, which I didn't mention just because I was talking about something else, but I hugely value the importance of responsible AI and what you said about it. Again, I think we cannot leave responsible AI to the technologists or to software developers. It's what humans do. And to go back to my talk, it's about originality and to produce original ideas. Again, we cannot just tell the ChatGPT developers, oh, you should generate more original output. They can't because of the way the algorithm works. It's about what humans do. And I think what humans do can be helped by regulation, but cannot be replaced by regulation. And I'm speaking as a European here. And so in Europe, there is a lot of effort on regulation of AI. And now recently, in the last couple of weeks, also regulation of generative AI, what we're talking about. So Europe takes a very strong regulatory approach. And I think this can help, but cannot work on its own. Just as I think this is the same with laws everywhere. Laws can help, but cannot solve the problem. I like the highway code, the law of how you should drive across Europe is basically the same in all the countries, but people drive very differently. And I think it's the same with AI regulation. There will be some kind of worldwide convergence. And again, we need to mention China in a positive light here. They also have made a real effort on regulating their AI. I think we see a kind of convergence in AI regulation. But this is not the end. It's what humans do. And I think what humans do is affected by culture, by tradition, and by so many aspects.
You, Fernando, for your question. So sorry, my Zoom crashed in the middle. So the next question is Tim. Tim, please unmute yourself.
Thanks very much, Philippe. You provided a very, very clear set of arguments, which I enjoyed very much. It's rather strange that there was logic in it, whereas you were arguing exactly the opposite for AI. But I'm working particularly on LLMs in education and learning, and I've just been writing a keynote that I've got to give next month, and it was lovely to have your ideas reinforcing much of what I said. I've got a tangential question, and somebody else may know it, but I've also been working very much on the environmental impact of AI and on the energy requirements. And there are so many different propositions out there and a lot of vagueness. This may not be an area you're particularly working on, but maybe we could talk offline, or if you've got some key figures now, because it's incredibly difficult to estimate. We've been working on some models, but there's just such variation in it. And my own concern is actually not so much the moral arguments that you've been proposing, because as I think Fernando says, it's out there. We've got to learn to live with it. I think I'd have different answers about how to resolve it. But any thoughts on the environmental impact other than it's huge and it's going to grow, probably logarithmically? But thank you once again ever so much.
Thanks, Tim. The companies are very secretive about what they do. On one of my slides, I mentioned about 400,000 processors to run the system. That are figures from Microsoft. You mentioned exponential growth, but I do see, and I've mentioned that in the talk, some models like Llama from Meta actually are scaling back and are going from 1 trillion parameters to 100 billion parameters. Of course, it's still massive, but this is this actually is a scaling down. Also, when specialized large language models are being developed, for example, in a medical context, they will be smaller models. They are smaller models. also from hearing what Sam Altman is saying about GPT-4. So people ask him, is there a GPT-5 and is it going to be larger still, and how many parameters and process will that need? I think he also indicated that really there might be a sort of a plateau being reached, which I think is a good thing. But if you're looking at environmental aspects, please keep digging, because we really need to ask the companies who run these systems for responsibility. We don't want to see a repeat of what happened with Bitcoin mining, where basically you had thousands of processors in a tent somewhere in the north of China or whatever, gobbling up lots of energy which could be used locally. So we don't want to see the disaster of the energy disaster of Bitcoin mining being repeated in AI. So yeah, I think research on environmental aspects of AI is very, very valuable.
Thank you, Tim, for your questions. So we are moving to Tarek now, and after that, we will have 2 questions from the chat. Tarek, please ask your question.
Thank you very much. First of all, thank you for this presentation, and I completely can relate or agree with what was mentioned about the need or the threat that there's going to be reduced originality in the future, and the need to find ways to encourage personnel who favor producing in-depth content over speed, which might happen with AI. Now, my question is, and I'm coming from a non-computer background, I know more about bacteria and life sciences, so kindly excuse if my question is oversimplistic. But when the public and myself became more aware of generative AI with the advent of ChatGPT, there was this initial hype, let's say, or over expectations of what it might provide. I mean, one thing I'm excited about myself is the prospect of, let's say, having those models that can go to the UN archives, or let's say 10 years of a certain country mission, UN country mission in a certain country, and looking at all the data there. I'm talking about meeting notes, recordings that it can transcribe, all sorts of things, and then extract information from it that we ask for it, and essentially conversing with it, right? Now, my concern is, or maybe the question is for Philip in that aspect, is, do you think there would be a possibility such things would be restricted and not be realistic, and that this information would actually be locked or retained behind a paywall, or not even behind paywall, not be available for the general public and be locked by big corporations like Meta and Google? Because that's what's happening right now. When we have social media and Google, we essentially have no idea of how much information they collect and use and how it's used. So do you have concerns that that would be the same for generative AI or language models, and that it would be mainly, like you said, by major corporations or states, and it would not be as useful as we want it to be? Thank you.
Thanks, Tarek. I have great hope in smaller companies using this technology. And for example, just to give an example, you could look at hospitals and medical care in Africa, for example, where you may have specialized needs. For example, the countries that are suffering from Ebola. You could take all the medical notes that are being written in these countries and put them together in a kind of specialized large language model to provide help to medical staff who have to operate in an environment where there might be an Ebola outbreak in the future. So that are smaller models, I think, could be made by smaller companies or maybe by governments. What you need the problem that arises there is the problem of confidentiality. So if you do that, if you look at all the medical notes being written in, let's say, Sierra Leone or so, there might not be that many. And if you put them in a large language model and then have somebody else use it, they may see confidential material. But I think this can be resolved with medical codes of conduct, etc. So I hope, and I pretty sure actually that there will be a lot of specialized large language models in the medical context, in management consultancy context, in the education context, etc. And that these will be run by smaller companies and also maybe accessible to communities worldwide.
Thank you, Tariq, for your question. So I also agree with you what you said at the beginning, because I see in the UN system, for example, lots of interest of people who want to use this kind of system to synthesize lots of knowledge and lots of informations, especially in the context of policy making. I think this is maybe niche application, but there may be something interesting to when you are trying to synthesize knowledge from using these technologies of large language models. So we are moving to questions from the chat. So Stefan, you want to ask your question directly to Philippe? Or I can repeat your question.
Sure. Can you hear me?
Yeah, we can hear you.
Okay. So Philippe, thank you for the presentation. First of all, it was great. Question for you. You mentioned that there may come a time, and I think you said maybe a decade from now, when generally we would turn away, I believe was the quote, from AI. I got the impression you were saying that we would be less, it would be less visible to us, not that we were going to stop using it. The question that I had is, one, am I interpreting that right? Secondly, if I am, are you envisioning a time when it's going to be so opaque and ubiquitous in our applications and how we're using it than it is now? And is there a danger in that, do you think?
Yeah. Hi, Steve. Yeah, I do think it will become as ubiquitous as spell checkers currently are. I think we ask very few questions about the spell checkers we use. And for example, when they make automatic corrections, or when do they give us an option between different words, or how spell checkers actually may influence the vocabulary that we use. Spell checkers also, for people who are multilingual, like I'm a Belgian, I often write emails in different languages. Spell checkers sort of secretly nudge me to move towards English, I find. So spell checkers are ubiquitous and are largely ignored now. I think the same will happen with the sort of content assistance that we are going to have from in the Microsoft software, for example. So yes, I think what you wrote in your chat, opaque and ubiquitous, are exactly the right words, and immediately that should raise red flags, I think, and make us think, and we need to work to make sure that worldwide people realize how they are affected by GPT, but also by spell checkers, by other things.
Thank you, Stefan. So we have another question in the chat from another Tim. Tim Kuchuk, you want to ask your question? I don't know if you directly, or I can just repeat your question if you want. Tim. So the question is it possible to use AI to control and regulate other AI systems?
That is possible. I think we are in the context here of control engineering. And of course, I had a PhD student once from South Korea, who was using AI actually to control nuclear power generation and to look for problems. So I think within the context of control engineering, you can have several levels of control algorithms. So for example, you can have an algorithm that adjusts something in a nuclear power station, and then you can have another algorithm that supervises the first algorithm. Yeah, the same for all sort of military applications, for example, drone and drone warfare. And it's sad we have to mention that, but unfortunately it's so common now. I mean, there are AI algorithms within the drones that select targets, but you can well envisage a second layer of algorithms that kind of supervises the first algorithm. So my answer to that is yes, and it's within the context of control engineering.
Any other questions from the audience? Yeah, maybe I can ask another question. So you said at the beginning that ChatGPT was trained on something like 1 million Shakespeare. So it's not that much words, in fact, but but the problem with this system is that they are very hungry, so they need a lots of data, and probably we are at the maximum. They use the whole internet, they use the whole Wikipedia to fit this kind of system. So now the only option is to use the synthetic data, so to generate new data to train these models. So, and there is I see recently that there is probably a problem, because when you start to use large language models, and you train large language models on data providing from the internet that already comes from large language models, you have this kind of feedback loop between the documents, the text that you produce, and the text that you use to train, that are coming essentially from the same system. So there are this kind of bad feedback, and the quality of the production becomes worse and worse. So we probably will see some kinds of decrease in terms of the quality of the large language models. So because they are basically depending on the quality of the human production. So if we start to feed this system with the production of themselves, so it might be a problem in the long term. So just want to have your thoughts on that.
Yeah, absolutely. And if we see more training of GPT on outputs it has produced itself, the output will become ever more generic and bland and so on. And I think that is a real danger. In terms of selection of input, though, I think there is so much knowledge in the world which is currently not included. And again, looking in a sort of United Nations context, there is so much cultural knowledge in smaller languages, smaller cultural groups, which really is valuable for the whole world, not just for these small groups. And it's a pity that GPT is going to sort of, and the same for the Chinese systems, institute the dominance, not just of dominant languages, but also of dominant cultures. I find that sad.
Tim want to ask another question?
Yeah, could I follow on from that and maybe move it to a much more kind of meta kind of question? I completely agree with your comments about bias. So most of my work is with the poorest and most marginalized in Africa, Asia, Latin America. So yeah, you're speaking to the converted there. But, and it's quite difficult to formulate the question, isn't what we've just been talking about one of the fundamental problems of the whole scientific model since the origins of the Enlightenment, in a sense that, okay, that we are beginning to get new ways of statistical thinking, perhaps Bayesian statistics and new ideas may be coming out of that. but essentially what we like to call explanation is really just very refined description. Now, correlation and regression, which underlie a lot of statistics, is about describing a relationship. It's not necessarily imputing causality. And so I've been thinking, particularly while Serge was asking his question, that how do we break out of this? And it also perhaps slightly touches on Fernando's question. I don't know if you've come across post-autistic economics. It's a horrible frame, but it's a group of, came out of France, economists who were trying to tackle this issue in economics. And it could be, and let's be positive, it could be that let's call it the crisis of AI might promote us to start thinking about science in fundamentally different ways. And maybe, Serge, the answer is to do some things which aren't accepted by the vast majority of scientists, as in post-autistic economics. I do a sort of thought experiment with robotics students, and I say, would you design a robot with a disability? And of course, they will answer no. We've got to make robots perfect. And I just wonder, and the focus on, in what you're talking about, stochastic and random, that maybe we should start introducing random faults in what we program. I don't know, but I think it's exciting that we could think that the crisis you're talking about actually moving in radically different ways in the scientific community. I maybe haven't phrased that particularly well, but I hope you grasp what I'm trying to.
Sure. To give a very brief answer, Tim, because we could discuss more about this. But yes, absolutely. It's my point about originality. We shouldn't just look at statistical correlations. We need original proposals of, for example, causality. What causes what? My personal view is that we need to allow people to make errors, but then the errors need to be corrected. There needs to be a mechanism, and what people say needs to be challenged. But if we just are going to let large language models dominate, we're going to have more and more bland stuff, and sure, a lot more output, but it won't be worth reading. I think we need to fight for original ideas, many of which will be wrong, but need to be proposed, challenged, investigated, and then we will find some real advances. But thanks for your comment, which are valuable within our discussion here.
I think there was a question from Barbara in the chat. Do you want to ask your question, Barbara, directly?
Hello, it's not actually a question. It's only, I would say, a commendation. I want to appreciate the fact that, AI and large language models are moving so fast, especially here in Ghana. The youth are all running onto it and working with it to write their thesis and all of that, forgetting the fact that as humans, we also need to be as original as possible. And so I'm happy about the fact that even though AI is helping in one way or the other, Philippe has been concerned on the rate at which we are probably degrading our humanity if we continue to hop on all the goodies that AI has brought on board. You get it? So all I'm saying is that I'm happy about the fact that he's talking about the fact that humans should continue to be humans and be original as much as possible. So yeah, it's a great presentation. Thank you.
Yeah, thank you for your comments, Barbara, and great to hear you're in Ghana. I think Africa has a lot to give to the world in terms of humanity.
Thank you, Barbara, for your questions. So I don't see any new questions in the chat or in the room. So maybe we are coming to an end for this webinar. So thank you again, Philippe, for this wonderful presentation and the very interesting discussion after that. So I think everyone in the audience enjoy your presentation and the way you convey very complex issues with very simple terms. So the next session of this series on generative AI will be organized in November. And so please have a look to our website or Twitter, X, whatever, social media platforms for future announcements. So thank you for joining these sessions. Thank you all, and see you soon. Bye-bye. Thank you.